All right, folks, let's do another problem involving a two-sample F-test. So in this one, we've got a biologist that makes a claim. They claim that the pH levels of a soil in two geographic locations have equal standard deviations. Independent samples from each location are randomly selected. At a 1% level of significance, is there enough evidence to support the biologist's claim? So again, conditions. We've got random. Yep, we have independent samples. Good. Okay, and what was our third condition again? Again, it was the normal distribution. And we should recognize that it's missing again. I will now add it in. And we have it. Okay, so which is going to be our population 1? What's going to be our population 2? Remember, we always choose the larger one. The larger one is this, so this is going to be 1, our population 1, and this could be a population 2. Now, I do want you to notice one thing if you haven't already spotted it. This is for standard deviation. Okay, notice it says equal standard deviations. These are sample standard deviations. They're not variances. However, we can still work with that. Not going to be a problem for us. So this would have some population standard deviation 1. This would have some population standard deviation 2. Our null hypothesis, our alternative hypothesis. All right, remember that we always put our 1s on the left, our 2s on the right. Very good. Okay, so the claim is that they have equal standard deviations. We know the equal sign always belongs with the null hypothesis, so this is our claim. That means the alternative hypothesis is that they are not equal. So let's get moving with this. Now remember that our test statistic of F is always S1 squared over S2 squared. Do not forget to do the squaring. Okay, we might be tempted to do 0.95 over 0.78, but those aren't the variances, those are the standard deviations, so we need to square them, and we get about 1.483. Okay, there we go. All right, what's next? Well, we need degrees of freedom. Degrees of freedom for the numerator, that would be this, so that's going to be 16 minus 1, which is 15. Degrees of freedom for our denominator is going to be 22 minus 1, which is 14. Our level of significance, again, is 0.01. All right, so now it's time to find our test, well, not our test statistic, we already have that, but our critical F value. Now here's what we have to be careful about. This is a does not equal, which tells us this is a two-tailed test. Okay. Now on the last problem that we did in the previous video, this is a right tail test. And what's going to happen on this is that we're always going to have right tail tests. Because it's skewed to the right, it's all positive, we have to have right tail tests. But then how do we do a two-tailed test? Well, we just make it a right-tailed test. We just have to consider what our rejection region will then actually have to be. So if I were to draw my F distribution, something like this, now we know a two-tailed test means we have to put some here and the equal amount over there. Now our level of significance is 0.01. So we know this has got to be 0.005, half of that, and this also has to be a 0.005. So because our table only gives the right tail, what we do is we look up this as our half alpha, and we use that table instead. We are not going to use the 0.01 alpha table in the back of the book. We have to use the 0.005. the half of that. So our test, I want to say test statistics again, our critical F value is going to be, okay, so now let's find it. We have to use the half alpha. So we're not going to use the 0.01, we're going to use the 0.005 table, which I have on A20. In my numerator, my degrees of freedom across the top have to be 15, so I find that. My degrees of the freedom, one lights, for the denominator are 14, so I'm going to go down until I hit 14. And I think I'm on it right there, 4.25. So that sets this right here. So what was our test statistic? It was right this, 1.483, which is not there yet, is it? So this means we will fail to reject the null hypothesis. Okay. And that the null hypothesis is the claim in this case. So if we're failing to reject the null hypothesis, we're failing to reject the claim, so there is enough evidence to support the biologist's claim. So with the two-tail, we don't have to worry about the left tail. We can only do the right tail. It's not in there. We should be all good, set, ready to go. All right, as always, let me know if you have questions. Reach out. I'm happy to help. I'll see you later.